Exercise 4 asks you to determine the total width of the cascade steps. And for this, I'm going to draw a little sketch again of the cascade units. The water flows via two fall heights of 0.5 meters, which I'm going to indicate with H. There's a couple other parameters which are important for this exercise. First of all, V0, which is the initial velocity when the water leaves a cascade, as well as D, which is the diameter of the water jet where the water leaves the cascade. And another value which we'll calculate in a second is X, the distance the water travels from one cascade to another. The first thing we want to calculate is the time that the water needs to travel from one cascade to another. For this we'll use the formula, which is a basic dynamics formula, H equals 1/2 gt squared. Since we're interested in T, we're going to rewrite the formula into T equals the square root of 2h divided by g, with h equals the fall height equals 0.5 meters. So this gives us square root of 2 times 0.5 meters divided by 9.81 meters per second squared. And this gives us a time of 0.32 seconds. Second value we're interested in is the D, the diameter of the water jet. We're going to use the following formula: d to the third equals qs squared, and qs we're going to calculate in a second, which is the flow per second. Qs squared divided by L net squared. So let's do this up here on the left real quick. The Qs flow per second equals the hourly flow divided by 3600. Hourly flow was calculated in the last exercise and was 12,000 cube per hour divided by 3600 is 3.33 meters to third per second. So we go back to the formula for diameter, and first of all we write it a bit since we're interested in the D. So D is equal to the third root of qs squared divided by g times L net squared, which equals the third root of, we just calculated, 3 times 33 meters per second cube per second. Sorry about that. It's supposed to be a in brackets, obviously. It's squared divided by 9.81 meters per second squared times L net. We calculated this in the last exercise with 20 meters squared. And if we calculate this gives us 0.043 meters for the diameter of the water jet. Next value we want to calculate is the initial velocity when the water has when it leaves the cascade. This velocity is given by the following formula: Qs divided by L net times D, and we know all these values by now. 3.33 cube per second divided by 120 meters times 0.043 meters. So the velocity that the water has is 0.65 meter per second. And now we actually get to the x, which is one of the values we need for the design. Again, this is simple dynamics. X, distance traveled, equals velocity times the time. We've calculated those values. Velocity was 0.65 meters per second, and the time was 0.32 seconds. So the length we get for x is 0.208 meters, and we're going to make this 0.2 meters. Since we're designing the cascades, we want to have a rounded value, and those 8 millimeters don't really make a difference when we design the cascades. So we have 0.2 meters for x. However, we want to calculate the width, and if we look back at the drawing, the width of one cascade is actually twice x, because we want the water to hit the middle of the cascade. So W equals 2x, which is 2 times 0.2 meters. So the width of one cascade is 0.4 meters. However, since we're interested in the total width, which I indicate in the drawing as W total, we have to multiply the width by 3. And this gives us our final result, total width of the cascades being 1.2 meters.